G'day and welcome. Today we'll be having a brief look at atoms and molecules. Even from ancient times, people realised that everything was made of small building blocks. A couple of Greek philosophers from about 500 BC named these building blocks atomos, meaning uncuttable. Nearly 2,500 years later, scientists finally had the technology to start discovering these building blocks. They called them atoms, remembering those philosophers. Absolutely everything you can see and can't see is made of atoms. The plastic in the chair you're sitting on, the wood and steel in your desk, the glass in the windows, and even the air are all made of atoms. Why did it take so long? Because atoms are absolutely minuscule. This is a picture of a human hair with a carbon nanotube leaning against it. A human hair is about 300,000 atoms across. Yes, you would have to split a human hair into 300,000 strips. Each would be one atom across. As technology increased over the last 100 years, scientists discovered that atoms are not uncuttable. They are made of even smaller pieces. A nucleus in the centre with an electron orbiting around it. This is a diagram of the hydrogen atom, the simplest atom there is. It has one proton in the nucleus and one electron orbiting around it. The next atom up on the scale is the helium atom. It has 2 protons and 2 neutrons and 2 electrons orbiting. The scale keeps going up and up and up, all the way to uranium, the heaviest atom you'll find on Earth, with 92 protons and 92 electrons. Some very clever people have put together this very complex table. All the different types of atoms are here. Each type of atom is called an element. So this is the table of elements. Don't worry about studying this table in too much detail, but there are a few worth mentioning. Here is hydrogen, the first atom diagram we looked at. The helium atom we looked at is right across the other side, also at the top. Way over here. They're not organised in a straight list. They're organised in periods or special groups. Another one you'll know is oxygen. Alright, let's get to the one that everybody wants to know. Gold is down here. Hang on a sec. If that's gold, why does it say AU for the symbol? Well, a lot of these substances were known from ancient times. Even Egyptian pharaohs were buried with their gold. The AU comes from an ancient language called Latin. They called it Aurium. You'll see the same thing with iron. The ancient Romans called it ferrum. And they called silver argentum. The interesting one is lead. They called it plumbium. Because the Romans made all their water pipes out of lead, we still use a version of this ancient Latin word today. Who do we call when we need someone to work on our water pipes? A plumber. way down the bottom is where you'll find uranium. All the white letters are atoms that you will not find naturally on Earth, but scientists have manufactured them. If you have a really good look at this table, you'll find a few others that you've heard of. But things you won't find is like plastic, wood, steel, glass, or even air. To get these things, we have to join atoms together to form a bond. Let's have a look at a few. When two oxygen atoms bond together, we get O2. This one is especially important because this is what our lungs draw out of the air we breathe. If we did not have O2, we could not survive. When three oxygen atoms bond together, that is called O3, but is more commonly known as ozone. Ozone blocks something like 99% of the harmful radiation from the sun. We wouldn't survive very long without ozone. When two or more atoms bond together, that is what scientists call Molly. No, not Molly the dolly, not even good golly Miss Molly. Molecule. So this is a diagram of an ozone molecule. Even different types of atoms can bond together. Here's a famous one. H2O. H for hydrogen, 2, saying there's two hydrogen atoms, and O for oxygen. Of course, we better know this as water. Beautiful, life-sustaining water. Even small differences in the molecular structure can change the substance a great deal. This is the H2O2 molecule. Two hydrogen atoms and two oxygen atoms. Just one different from water. It's better known as peroxide, or what people bleach their hair blonde with. Yes, one extra oxygen atom changes it from beautiful water to bleaching peroxide. Atoms get incredibly complex, even enough to challenge the greatest minds on Earth. This is just a quick introduction to give you a bit of an idea of what's going on.